Oh, hello. So we're finishing the autism spectrum disorder because I thought it would be really nice to add some additional information so that we can look at these top genes and see if any of them do show up with the androgens and the circadian rhythm genes that the published article that put out those gene expression profiles said was found. So I'm going to go ahead and share my screen. I have the link to the document in the details of this file that should get published whenever you look at this. And I'm going to share the entire screen. Yesterday it cut out early. I'm not sure why, because it said I was still recording after 2 hours, but it only cut it up to an hour. So you didn't really see anything. You didn't miss that much, but we did do the 4-class model on it. And it's in the document, so you'll be able to use that. We're just going to pick up where we left off. I'm going to go into this folder. And this one right here, we'll just open up, run all the chunks, and then I'm going to open up the other file that we're going to merge with these top genes. We don't really have to set the working directory. I'm not going to. And now I'm going to go ahead, while that's running, we're going to go to the our programs. And then it's this one. The gene study is GSC 271-486. I'm going to go ahead and copy this. Copy as a path. And then I'm going to put it at the end. Hold on. I think this is link. It's not going to copy any of this other stuff. So we're just going to do exactly what I said. I just was putting it in there. Well, let's see what it is. Okay. So we're just making a few chunks right now. We're gonna copy and paste those. I just got done with some light tidying up. It did rain last night. Not a bunch, but enough to leave some water in the backyard. It'll probably dry up later. It's mostly cloudy today, so maybe tomorrow for sure. And today we're just gonna do this. All right. Okay, so I'm gonna copy that path, and I'm going to put include equals false, so it does not include this information for us, just in case there's a hacker that can break my firewall to my computer, do remote in here, and then find a wormhole into doing some mischievous stuff like hackers do. Oh, so I'd never even copied it. Hold on real quick. What the heck? That's annoying. Okay. So we'll go back to the file, copy as a path. That happens. Oh yeah, because I copied the chunks. Oops. All right. So now see, these little backslashes need to be forward slashes. So we're gonna go ahead and hit this magnifying glass, put in selection. We're gonna put a backslash in, then we're gonna replace it with a forward slash and replace all. Make sure it's highlighted. It's selected in selection. 7 occurrences. That sounds right. It looks like our code has finished running, and include equals false, but we're going to go ahead and put another one here that puts eval equals false for this one. But we're going to just leave it like that because include equals true is default. Eval equals true is default. This one we're going to evaluate every time, but we actually don't need this file name. I'm going to put another one that says path so that it sounds like yeah, so it sounds like yeah, so path not seen by anybody. The first one, the second one is, and this is just the location of the file on your desktop. There is a link to it from my Google account. I'll just go ahead. And we're using another study. That was provided in that study. And it was GSE 271486. All right, and I'll give you the link to that because you can go get it. See, I'm gonna go put that here. Ooh, this one already had a database in it. I know it did because I didn't get it myself. It was pretty useful. So we'll just do that. We're gonna go here. Okay, it was this one. What do you think? So if you go to this link, let's just go copy this. It's right here. You just go to the bottom. This is where we get all of our files. And they provided it for us. It was already in an Excel file. And this file has that information that I'm sharing with you right now that we're going to be merging. This is the information about this series, but they had already put together everything in an Excel file. So you'll see if you download it. You'll see some of it when I import it into this our document, our markdown. We're just using the same one. It says part 1, but it's just so that when I republish it every time, it saves to the same one. Okay, we've done that. Let's go ahead and remove this file name now because we're going to use this. Cut that. And this is going to be our ensemble names. So we're going to go ahead and read.csv. It might be table, but no, it's CSV. Yeah, because it says it on the extension. Header equals true because I know it has it. And then we'll just leave it at that. So we got to set the path. And then we don't run this one. So whenever we run all chunks, we don't have to worry about this. But when we manually do it, we might accidentally press this and be like, well, there's no path whenever we get here. So just make sure that when you manually do it, like that. Same with knitter. Okay. And then, oh, I got to set working directory actually to path. To path, okay. And then let's put warning equals false up here so that it doesn't push out all this warning information. If there's an error, though, it won't even let you knit it and stop running all the chunks too. All right, let's look at what we are looking at. Well, it's a huge file, 50,000. Let's just put that there. 50,868 by 16. And so that's huge. So we'll go ahead and just look at the first 10 rows. Oh, I always put an E at the end. Okay. Gene ID, gene name. See these gene names right here? These are the names that we want, not the ones on the left. These ones right here. We're going to merge by that, and we get a description of it, what it is. So they already gave us this. If there's a long description, we just hover over it and it'll say. It'll say the location on the chromosome. Here's the chromosome number. All autosomes are with a number. The X or the Y is with that is the sex chromosome. And then we have, for that study, we have these other values that really are useless to our study because they are about Epstein-Barr virus. Well, yeah, well, maybe not. Can really get lost in creating some of the stuff. But we're not going to look at those ones. We're just going to look at... So we're going to... we will need the gene IDs anyways when we add them to our pathology database. So let's look at the column names ensemble. Okay, and we're going to shorten this ensemble 1, 2, 3, 4. We only want the first 4 columns. And it's going to be ensemble 1 through 4. And then, did it again. Oh. And here it is. We can do the same thing. And just the first 10 rows. Let's look at it. Okay, so it's the gene name, description, locus. I thought I had a start stop, but I guess it's not on this file. It must have been somewhere else that I seen. Well, I did see it, but it's not on this file. So we'll go ahead and it's really from the last project. We're going to merge this. Now, our top genes database is the one with 44. We can actually go look at it. I think it's the top 44. Let's just look at where we were last time. We didn't write it out to CSV after we did the predictions. We were using the top 44 matrix, but from the matrix, we got it from the top GB IDs. Okay, but we changed it into top genes, which is 49. And then we made it top 44 with a capital T. So it's this one. Let's just put it in the top. Those are our samples. And we have 119 rows. It only goes up to 50. So let's go to the very back. Still samples, 116 samples. The gene bank accession ID, the ASD group, and the gene ID. So we're going to go ahead and merge that. Let's make sure our ensemble 4 is there too. Okay, so gene name and ensemble 4. And then we're going to have the, let's go ahead and merge this with, all right, that. But you know what, this big data frame though, language with all of the variables, we need to save that one too, because that's useful also whenever we want to put it in our pathology database to combine all of the tens of thousands of genes from that study to predict with the top genes, limited to like maybe 1,000 or so altogether, to predict all of the pathologies we went over. Just based on the gene expression, even though it won't be the same tissue type. It'll just be amusing, but if it is significant, then that means there is something there. It's really just because it's just neat, because you can always develop new ideas from other ideas and stuff. So, neuroplasticity, if you didn't know about it, it is very useful because you may think that you are no longer going to remember something, but you will remember something as long as the axon to that nerve root is there and it wasn't destroyed by something like ischemia. All right, so we're going to merge this. I'll just put that. We're going to merge the meta-information with the top 44 data set and with the big data set for use with our larger global goals in a larger pathology machine model. Predict all pathologies we have looked at so far. Okay. And we can, okay, so these actually aren't very good definitions. I believe there is a way we can just Google GeoQuery, and I believe we will maybe look that up and see, because that one I think will give us the actual gene card's definition without having to manually do it. But we'll see. It's only 44 genes, so. All right, so let's go ahead and merge. And I want this one too. We'll do that one afterwards. Okay, we'll just merge mid top 44. Merge. Let's do the top 44 with ensemble 4 by.x is the name of the merging variable, which in this one is gene name, all lowercase, underscore between. And oh, actually that was the y. Okay. And then I believe we do have to do it in order. Y.x equals, it doesn't matter if you use single quotes or double, but I'll just be consistent. It will still run. Top 44, its name is gene ID. Okay. Gene ID. And then let's look at let's just look at the column. There's a lot of samples. So we do have now we have so the gene ID is here. But see, now there's an ensemble ID, which is the gene ID from ensemble right there. And then the description and the locus. So what we're going to do is I want to put the gene ID at, it would be nice to see that actually more closer together. So let's just go ahead and rearrange these in order. Okay. So our new data is top 44 meta. It's going to be meta top 44. And we're just going to rearrange the rows. So it's going to be 2 through 13, 14, 15, 16, 17, 2 through 117. And then we're going to put 1 to 18 through, oh, wait, not 118 through 122. And that will put everything at the end. Or we could just do like, let's just do this. Let's just cut that. And paste it and put it at the beginning columns. And then page table top 24 meta, just 1 through 10, first 10 rows. And then get the gene ID right here, the gene bank accession number, the lowercase gene ID for the ensemble ID, the group, and then it'll say what it does. So I think I want the description before the gene bank accession number or after the ASD group. It's going to cut it off anyways, but well, all right. So we'll just do that. So we have, there's only 42 rows, so let's just put the whole thing here. Okay. And ATP binding cassette subfamily B member, atom, metallopeptidase with thrombus bond in type 1 with T5, aquaporin 7, activating transcription factor, Becklin 1, BMP binding endothelial regulator, centrosomal protein, Chimerin 1, CNKSR family member 3, cyclin internal domain containing. I think they go to KEG and they see, okay, they have cystatin F, FAM 111A, divergent transcript, FGGY, carbohydrate kinase, 4KED blocks for aminotransferase cyclodeaminase, N-terminal like Kelch repeat and VTB domain containing 2, Macorin ring finger protein 1, muscular LMNA interacting protein, twice, myosin 1B, nucleosome assembly protein 1, like 1, neuron navigator PB at homeobox 3, protein arginine methyltransferase 2. This has a duplicate. Presenilin, yeah, because it's not the matrix. So this is all of it, and it tells you where that was a top gene for the class of autism. Replication timing regulatory factor 1, that could be related to timing regulatory factor, possibly circadian rhythm. RIC1 hormone, RAP1B. Okay, and then we'll go to the next one. RPA interacting protein, septin 6, SLAM, family member 8, small nuclear RNA host gene, stimulator of interferon response, TET methylcytosine dioxygenase, THO complex, TCDD, inducible poly, TLC domain containing. terminal uridyl transferase 1, WNK lysine. Okay, so it's not really telling its description. Let's go ahead and look and see. But we can look at the chromosome. Oh, yes, it does have the chromosome location. The locus. Get a lot of okay, so there's 11, 12. There's a sex chromosome there. One of the sex chromosomes are usually having to deal with pathologies that men inherit, or the males inherit. Various chromosomes, and yeah, so not really something sticking out. I was like, oh, the most. It's not like there's a chromosome missing. I didn't see. Well, there's some. Let's do. Look. Split by colon. Okay, the chromosome location. Oh. Well, it won't really be too useful. It's only one sex chromosome. I think there are more, but okay, there's only one. Let's go ahead and look up GeoQuery and see what we can do. Let's see if we can look up to retrieve gene summary. Here's one way of installing them. It is a bioconductor, but the BioC manager is the option. I have to click in and then library GeoQuery. We have to retrieve the data set from within there. View dataset structure, extract expression matrix. Quick summary of expression values. No, that's not it. The gene, okay. I want to see if it pulls up the gene cards or NCBI gene summary. Download geodatasets, retrieve supplementary files, get RNA-seq quantification, search geo, open geo. No built-in gene cards API. No direct one-to-one integration. Okay, yeah, so I probably can't. So we'll get back to this one. I'm going to go ahead and end the stream. And then after, I'm just going to merge it with this other big data, but it's not really what I was looking for because it didn't really have the information that I wanted. So it's not really that useful. Yeah, so and for this one I can't really merge it anyways because I don't have the actual I could probably merge it by the gene bank accession ID, but I have to go to the one that I actually merged it with, which will be one of the larger ones. It'll be smaller than 41,000. Well, maybe not. Okay, so okay, platform. Okay, so there's the platform. And then when we merged it, short platform. That was only the ones we wanted. All right, I feel like we added the gene bank accession ID to this though. I'm not seeing it though. Let's see, maybe it's in here and just all this other stuff. No, it's not. Okay. Let's just scroll up to the top and we'll just keep looking at the merge. Because we didn't do that many of them. Oh, we only merged it whenever we extracted the top expression profiles. So we never merged it. I guess we could do like the short platform merging on the user ID. So let's do that. Merge it with the short platform. X equals y equals UID, short platform UID. Okay. Let's look at the column name. I have to remove some because I don't want these duplicates. So we can remove the spot ID, the ID, and UID RC. Okay, let's see. UID RC. Let's go to the very end. Yeah, so we can remove this ID column and this ID. Okay, so we're gonna keep the gene bank accession ID, and that's the only one we're gonna keep. So we're gonna get 1, 2, 3, 4 through 17, 18, 19. Okay, so 4 through 119 for the samples. We'll go ahead and keep the mean values and fold changes and the ID. Actually, so we'll just make it through 126 and then 28. And it's going to be, we're going to name it big. Okay, so we'll just name it the large DFDB stats added. Okay, and it's going to be of this one, big GB added. And then we'll go ahead and look at our column names. Here. 518 to 633 should be for the samples. Plus we have the means of each group, and then the fold changes and only the gene bank accession ID. We'll get rid of that one. We'll get rid of that one. Now we got to merge it with the ensemble 4. But let's put this up here so we know which one we're using. Okay, it's that one. GBACC is what we're merging on with the, oh shoot. Yeah, because actually, I remember now. We cannot merge this with that because it doesn't have a gene bank accession ID. That's right. So that's too bad. Oh well. Oh, that sucks. So all you have is a large thing of gene bank accession ID. So it's a big data set of that, but it doesn't tell you which chromosomes it has. So nothing we can do with that. All right, so we'll just end it there. Okay, so we do have the top 44 with their gene description right here. Gene ID. No, it's not that one. It is actually. Let's get rid of that one too, and that one. Okay. So we do still have the large data set though, so we could still use it. We just don't have the genes for it. It's just a gene bank accession ID. So this other one we made top 44 meta with a capital T. Top 44 meta. That's the one that we made. That has the description and that location. The gene ID with the gene bank accession ID, but only for our top genes. Make some notes on that. Okay, so for this top 44 meta one, I guess we will go ahead and write this one out. We're just naming it row.name. Okay, so we're naming it similar. Need to describe it. Set no names to false because we do not need this. We're going to put evaluate equals false so that we just run it this time and it's not going to keep saving and overwriting whatever it is, because if there's a mistake later on, it will overwrite it. And we can run it manually. Okay. But when we run it through the chunks, running all chunks or knitter, it won't run it. Okay. And then we're going to go ahead and write this other one out to the large that one. Large data, and it has No gene IDs, only GB ACC IDs, and it is, wait, wrong direction, 41,472, 2x y 124. Okay, .csv, where.name equals 8. Needs gene IDs. And we'll also put eval equals false. And, okay, so that will be it for today. I guess I could upload this one and then leave a link to it, because the other one's probably going to be too large of a file. But you can go check that out when you get to it. I'll go ahead and knit this out.